Hey, welcome back. This is episode 10 of the Salesforce Architect Playbook. Today, Salesforce Identity and OAuth 2.0 Security Architecture. Mastering JWT Bearer, PKCE Web Server Flow, Named Credentials and Headless Auth for CTA Board. Let's get into it. Here's what we're covering today. Enterprise Identity Topology and Salesforce OAuth roles then, OAuth 2.0 Web Server Flow with PKCE versus User Agent Flow then, Server-to-Server JWT Bearer Token Execution Architecture then, Modern Named Credentials and External Identity Governance then, Salesforce Headless Identity and External User Provisioning then, Mutual TLS, mTLS, Security and Network Hardening Patterns then, Enterprise Identity Anti-Patterns and Common CTA Audit Failures then, CTA Decision Matrix, Choosing the Right Auth Flow. Stay for the last one, it's the piece most tutorials miss. Let me explain this simply. In enterprise architectures, identity and authorization are where most security breakdowns happen. Today, we are dismantling how Salesforce OAuth flows work under the hood and how to architect zero-trust integration security for the CTA review board.
I used to think named credentials and OAuth flows were plug-and-play, but I keep running into token expiration issues and certificate rotation headaches in enterprise setups.
When designing enterprise identity architecture, architects must first distinguish whether Salesforce acts as the identity provider, service provider, or OAuth authorization server. In multi-system landscapes, relying on native Salesforce authentication without centralized IDP integration introduces identity fragmentation and auditing gaps. Connected apps serve as the primary gateway for regulating external API access, defining scopes, IP relaxation, and OAuth policies. Misconfiguring connected app security policies is one of the most frequent findings in CTA review boards. A robust topology always decouples identity assertion from API authorization. The OAuth 2.0 Web Server Flow with PKCE is the gold standard for user-facing applications requiring access to Salesforce APIs. The user agent flow exposes access tokens directly in HTTP redirects, rendering it vulnerable to token leakage via browser history and cross-site scripting. By mandating proof key for code exchange, architects eliminate authorization code interception attacks even in public clients. Never store long-lived access tokens in client-side local storage, always rely on secure, HTTP-only session cookies or refresh token rotation. For unattended automated background integrations like ETL jobs or middleware syncs, the JWT bearer token flow is the prescribed CTA pattern. It eliminates interactive user logins by using an RSA SHA-256 digital signature backed by an X.509 certificate. A crucial prerequisite is pre-authorizing the target integration profile or permission set within the connected app settings to avoid user approval errors. The primary trade-off is certificate lifecycle governance. Failing to rotate expiring private keys will completely break mission-critical integration pipelines. Writing custom Apex code to manage OAuth tokens, header signatures, or refresh logic is a massive enterprise anti-pattern that creates severe security vulnerabilities. Named credentials completely abstract authentication, securely managing credentials, endpoint URIs, and token refresh in the platform kernel. With modern named credentials, architects can decouple endpoint definitions from external credentials, enabling granular credential sharing across multiple endpoints. Always leverage per-user or principal-based authentication models in named credentials to enforce end-to-end auditability and principle of least privilege. Modern digital experiences require custom front-end applications built on React or mobile SDKs while delegating identity verification to Salesforce. Salesforce Headless Identity APIs allow developers to construct fully custom, white-labeled login, registration, and passwordless authentication flows via headless REST APIs. Architects must implement Apex registration handlers to execute just-in-time user provisioning, contact matching, and account linking during the headless registration payload processing. Always combine headless flows with reCAPTCHA enterprise and rate limiting to defend against automated credential stuffing attacks. High-security environments in banking, healthcare, and government often mandate mutual TLS authentication to establish two-way cryptographic verification at the transport layer. While standard TLS only verifies the server's identity, mTLS forces both Salesforce and the external API endpoint to present X.509 certificates before establishing an HTTP connection. Implementing mTLS on port 8443 bypasses traditional IP whitelisting limitations and protects against man-in-the-middle attacks. However, architects must account for certificate chain validation overhead and ensure automated certificate renewal workflows are operational. A frequent failure mode in enterprise architecture is utilizing generic system administrator profiles for integration service accounts, which violates the principle of least privilege. Another severe anti-pattern is hard-coding client secrets in Apex callouts or client-side JavaScript code, exposing secrets in debug logs and version control repositories. Additionally, failing to configure IP relaxation to enforce IP restrictions in connected apps bypasses network boundary protections established at the profile level. Architects must enforce automated static code analysis and credential scanning in CI/CD pipelines to prevent secret exposure. When presenting before the CTA review board, you must justify your identity and integration authentication selection using a deterministic decision framework. For interactive web apps, choose Web Server Flow with PKCE. For backend integrations, select JWT Bearer Flow with named credentials, and for B2C portals, utilize Headless Identity. Evaluate trade-offs across maintenance complexity, security posture, certificate management, and user experience for every interface. Always quantify the operational overhead of key rotation against the regulatory compliance risks of insecure authorization flows. Alright, let's wrap up. Here are the key things to remember. Always use OAuth 2.0 Web Server Flow with PKCE for user-facing single-page applications. Eliminate passwords in server-to-server callouts using OAuth JWT Bearer Flow and X.509 certs. Never manage HTTP auth headers in Apex, leverage modern named credentials and external credentials. Decouple corporate identity, SAML/OIDC, from API authorization, OAuth, in enterprise architecture. If this helped, hit like, it really helps the channel. Next up, Episode 11, Enterprise Data Governance, Shield Encryption and Field Level Security Architecture. See you tomorrow.